we're already 3-4 minutes into the meeting session. So is it okay if we just start?
Yep.
Yeah.
Yes.
Right. Okay. First of all, I would like to welcome everybody on this bright morning, at least in Ireland. So we at MTU basically leading this workshop. And the purpose of this to basically share some education and awareness about the digital learning for engineering laboratories. This is particularly under, the project, European Horizon project called Village, which is basically an acronym for Virtual Innovative Learning Laboratories for Global Engineering Education. And this project kicked off last year, and we are already in month 12 into this project. And the main focus of this project was to re-examine the post-pandemic teaching processes and needs for engineering instructions. So one of the main focus is on the engineering instructors and students for better learning and education, and especially for their laboratory practices in a multidimensional and multicultural environment. With that, I would just also would like to mention that as I already stated, the proceeding of these workshops are recorded. I would like to request all the participants to basically attend evaluation questionnaire. I will also post this in the chat, so please feel free. Though we also have the emails for all the registered attendees, we may also send a request by email to fill in these forms for the purpose of evaluation. And towards the end of this workshop, we will also capture a group photo with all the attendees. So I would like your presence till the end. This is the agenda, how we will proceed. This workshop is basically started approximately 11 o'clock. So we expect to last it for next 2 hours. So with that, I would personally request Farhat if he would like to start with a project overview and share some details related to the project.
Sure. Would you please give me the screen share privileges?
Yeah, sure. Just is it in the Can you try now?
It didn't work. I mean, if you want, you can make me a co-author when you click on my name and left click on my name.
Okay, I'll just do that. So I just did it for us. So can you just try?
I got it. Please let me know when you see my screen.
Yeah, it's clear and visible.
Okay. Hi, everyone. I would like to say thank you for being with us today. And also we are happy to share what we have done so far with the Village project. And also I am gonna share the basics and some overviews about Village project. Village projects and the Horizon project, as Sagab said, that it just founded last year, is the long name of Village is like Virtual Innovative Learning Laboratories for Engineering Education, Global Engineering Education. So it is one of the very important projects for us too, because it's basically projects the new terms of understanding virtual laboratories. That's why we just made a little bit strong, not with actually strong effort in it. So I'm gonna explain very soon. But first, let me explain what the MSCA, which is Marie Curie Action Staff Exchange Project, is that project. This is it's like as you know that it's a staff exchange project, but at the same time it's research and innovation. So all the organization come together in a one purpose and sharing their experience and building a new understanding about this new maybe creating new knowledge, skills, and career development. So this is the nation or the soul of the staff exchange project. So we will see the project partners, some of us academic partners, some of us SMEs or the companies. So let's see what is the main stuff exchange objective here is, let me make smaller here, is an international and also intersectoral, which I said like academicians and in private companies, and interdisciplinary and also mobility of research and innovation stuff comes together, which we called secondments. Secondments is basically you are visiting each partner around 1 month. You're sharing your experience and also the new knowledge that you are gaining during these mobilities. So this mobility we call secondment. Maybe you can you're gonna hear sometimes what the secondment is a secondment, basically this mobility. Knowledge transfer between participating organization, which is the strongest part of this project, these kinds of projects as well, and also collaborating between the academic and non-academic sectors, including SMEs, and also cooperation across the globe. We have partners also in Europe, and also we have partners from Azerbaijan. So as a specific summary of the project is, we basically in this project try to aim to re-examine the post-academic teaching process and needs of engineering instructors and students for laboratory practice in a multidimensional, multicultural, and multidisciplinary context, which means that, as you know, that we passed through pandemic, and also as a Turkey aside, we passed through the strong, massive earthquakes. So after that, we try to use distance learning and technology-based learning environment a lot. So after that, we decided, so do we have a roadmap for that, especially as an instructional design model wise? So in this project, to create an effective and sustainable instructional models while developing a pilot virtual lab and its learning materials to test and the proposed model. That's why we go through the first section, more like literature review that I'm going to explain later on, to understand the gaps and differences between what we are doing now or what we should do. In this point, Village is a joint research and innovation project, as I said, in the context of generating a sustainable learning model for virtual laboratory engineering education. So we have partners from universities and also companies and SMEs in Europe and beyond. As I said, we have partners from Europe and also one partner from Azerbaijan. So behind the state of the art, this project aims to not only to design another virtual lab, but also design a suitable model for engineering laboratories education based on as I said, these three very important keys and the topics that we are focusing on, which are multidimensional, multicultural, and multidisciplinary. That way, we are analyzing all our fundings and our collective data this way. So as I said, that here is our partners. So you can see some partners from my left side as an academic partners, and the right side more SMEs and the companies. And also you're seeing some G3 and S7 or G1, which refers like G3 product and process engineering experts, S7 educational experts, and G1 computer science and informatics experts. So some places you are gonna see G and S together. It means that in this partner, we have also like product and process engineering and also educational experts. So these are the partners, and you're seeing the countries. And we have 10 partners in this project. So this project started last year, and also it's gonna be 4-year project for the 8 months. And our plan to end this project 2027. And the budget of the project is, as you see, that 837 and 200 euros, if I said correctly. And sometimes saying number is not easy to say, but this is as you see at the same time screen. So here's the work packages that we are working on. We have 6 work packages. Basically 3 of the work packages is more like getting data, research-based packages, and last 3 more like career development, project management, and dissemination communication sides of packages, work packages. So we are now in work package 1 and go through the work package 3 actually. So now what we have done so far is just analysis of instruction design models for virtual engineering laboratories, teaching for the new normal. We call this a new normal because after the pandemic process, the normal is to new us. So we are using more technology. We are different looking to the technology, especially in education. So our next work package is needs analysis for the engineering virtual laboratories instructional models. And the third work package is development of the learning model for the innovative virtual learning and laboratory. So here is basically we are trying to find the best model if you find. If not, we are trying to create develop the new model just for virtual learning laboratories. So, and also the other perspective, another important point of this project is the career development, because we have senior researchers, we have junior researchers, we have the perspective of the new people to see, oh, what's the instructional design model, or what is a database, or what's the virtual laboratories might be side of knowledge that we are getting. So it's just for us as an academician, as a new understanding of what companies think about it. And the other side also the same. The companies try to understand what the academy think about the learning environment, especially virtual laboratories. So if you like to just follow us, and please follow us. This is our website, and the website is like a dynamic one. It's changing almost every month. We are trying to add new things, and also we are sharing our process, as you see, the Instagram, Facebook, and LinkedIn account. Please follow follow those accounts, and also you can follow what's going on with the village project, and please share with your ideas or your thoughts or comments with us, that we can do much more better with your inputs. So briefly, it is what Village Project is and what's we are gonna do or what we have done. So we are finishing work package 1, and now we are on designing a database for instruction design models right now. So thank you so much for listening to me, and I think that's it. If you have any question, please ask me. You can ask me right now, actually.
Thank you very much, Farad, for your brief introduction into the project as well as the layout of the project. So please, anybody has any questions? Please feel free to share your questions. Farad is here to respond to those queries.
Or you
You
can
can
write
use
me
your
down.
mic. You don't really need to use a chat box. You can use your mic to basically ask any questions if you have any.
Then thank you so much.
Right. Thank you, Farad. Okay, so the next on the agenda is basically, I hope you can see my screen now.
Yes, yes, we do.
Okay, right. So we just had a brief overview about the project and the progress so far. So as we said, like Farhat mentioned, we are early into this project and it's a 4-year project. So we just going to start work package 2. We just started in the February. So, the journey is still a long way to go, but we look forward to your feedback and your input onto that project. Next, I would like to invite the lead from MTU, Couple, if he would like to give a little brief introduction about the virtual lab platforms, the existing state-of-the-art tools and technologies there, and utilization of some immersive technologies.
Sakib, can you allow me to share the screen?
Yeah, just if you just give me a second, I'll just. Can you try?
Yeah, you you can see my screen, right?
Yeah, can hear you as well as we can view the screen.
Okay, great. Thanks, Sakib, and also everyone for joining this workshop. And so it's about digital learning for engineering laboratories. Basically, this is a part of dissemination of, let's say, our work package, and we're heading towards, this work package too, as mentioned by the Firat, and working on that already. And today I'm going to talk about the virtual platforms. The title is delving deeper into the virtual platforms. And me and Sakib are from the Department of Computer Science, Corp, MTU. So the roadmap, let's say, for the today's talk is we'll go with the introduction that what it is about, and moving on, we'll discuss some functionalities of virtual lab platforms, what it offers, and advantages and disadvantages of the existing, let's say, platforms, and also in general as well. What are the popular platform exist, and we'll go through, let's say, one of them, and have a look into that, and also let's say experience that, okay, how does it work and what they are offering, and also it's very important how we can choose the right platform, either it is for, this students, or let's say for the faculty members, let's say teaching members as well. And at the end, we'll conclude, let's say, I'll conclude my talk. So starting with the introduction, just mention that, okay, virtual lab platforms. And we are looking at, especially when the COVID happened, we were looking into different, let's say, platforms, let's say how they work and how they can, let's say, occupy space, how they can help. We have explored everything, and Therefore, people are came up with a number of, let's say, platforms as well, and are utilizing their, let's say, benefits as well. So it's about how they have revolutionized education by offering a safe, sustainable, accessible, and personalized, practical, and interactive alternative to the traditional laboratories. So they are offering a safe environment because you are already doing a virtual experimentation. You are not attached to any sort of hardware, so you are not away, let's say, worried about more of a safety procedures, protocols, that you are going to touch, because you are not touching any sort of hardware there as well. Sustainable as well because it offers a, let's say, huge range of, let's say, benefits, and also it's easily accessible as well, because you can, let's say, from any part of the globe, you can do the experimentation, and let's say this is offers also a personalized and practical interactive alternative because you can change the number of parameters. So you can introduce number of parameters, you can change a number of parameters to, let's say, work on a different experimentation. And that is very different to this traditional laboratories we have. It's very difficult to have, let's say, make changes and see the different outputs, let's say, with the variation of the parameters. So this is what we are looking into, this virtual lab platform, how much they are effective. Functionalities, they do offer interactive simulation, let's say manipulating variables, as I mentioned, and observe reactions, outputs, and this collecting data and within a safe and controlled environment. This is very, let's say, standard that we are used to, let's say, use different simulation softwares where we do, these kind of manipulations and observe different, let's say, outputs and collect data as well. And that, let's say, comes up with the context of engineering and, let's say, the teaching different science subject is very, very effective, and also beneficial as well. The gamification, number of platforms do incorporate, these points, badges, and leaderboards, just to enhance, this engagement, or whatever, this their motivation for the students to get to be in there, for an hour or two, and do some experimentation is a great, this addition to, these platforms they do offer. Virtual lab platform offer different experience, so let's say 3D models, animation, real time data displays, and adding in concept comprehension as well. So just to I think it's a great tools that offers a variation of experience, this like 3D models, animations, and that helps to get engaged with the audience as well, especially to hang on, with the students. It's very important to get them engaged and let's say teach them accordingly as well. Pre-lab activities. Some platform offer pre-lab activities to introduce students to the experiment purpose, hypothesis, and procedures. So it's very important. Let's say you have, let's say, some sort of platform where you can, do pre-lab activities before, let's say, getting into the hardware of, let's say, into the actual environment as well. So it's also one of the, let's say, great functionalities that they carry on. Assessment tools, especially for the instructors, they do have, different, let's say, assessment tool for the quiz, analysis exercises, just to evaluate that student learning engagement. This is again important because as we move, let's say, towards, virtual platforms, the engagement and section is very important to, let's say, monitor and, put into, let's say, focus for sure. Collaboration features, certain platforms enable collaborative virtual lab experience and fostering team and communication skills. This is what we are also looking to that, let's say, project. Let's say this collaborative virtual lab experience. So let's say from different, let's say, partners as well, and to have a great communication over the number of, let's say, experiments that students and, this faculty members and other members will do. Moving on the advantages quickly, accessibility and scalability. We already discussed about that, okay, they are accessible, virtual labs are accessible from anywhere part of the world. All you need to require is that, this internet connection, and it's also relatively easy to scale those virtual labs compared to, this existing hardware, let's say, or physical labs generally. They eliminate the risk associated with the hazard materials and complex procedures. You don't have to really, let's say, worry about that much, compared to the physical labs. And this is again, cost effective. This leads to also cost effectiveness as well. And we do need to have, let's say, understanding that, okay, everyone can't afford that physical experience or the physical labs, let's say, hardware or let's say resource requirements. So it's kind of let's say cost effective as well. Repeatability, let's say experiment can be repeated with the different variables. You can just manipulate within few microseconds and observe the output, and collect different data sets for your analysis as well. Virtual labs offer a consistent learning experience across different institutions or locations. They can be, let's say, very effective, and also you can, let's say, with a diverse set of experiments and the data and the analysis, one can, let's say, look into the standardization of that those virtual labs as well. Data collection, analysis, and security. Student can collect and analyze data more efficiently, fostering critical thinking and data interpretation skills, and with the security at the core. I believe, this security could be the issue, but, it's more of, let's say, how you, let's say, build your, let's say, platform for the students and to analyze data and do experimentation over the time. Technological literacy. Virtual labs equipped with the cloud-based tools, virtual technologies, and remote collaboration tools, enhancing their readiness for a tech-driven job market. So you come to know about how the technology is evolving. You get into that, and you are exposing different, let's say, platforms or the technologies to student, to yourself as a teacher or the faculty member who's, let's say, teaching. I'll quickly go through the, let's say, the disadvantages, let's say, limited hands-on experience. Of course, is an alternative to, this physical labs, not a completely a replacement that we are talking about. The second one is technical issues that might arrive, because of the fact that we do need internet connectivity, and that can, disrupt the learning experience as well. Similarly, as well, over reliance on technology. And the last one is the cost of platforms as well. We need to have, let's say, that platforms may have subscription fees which cannot be affordable by number of institute around the world. Maybe some part of the interior, or let's say, developing countries or underdeveloping countries cannot utilize. We look into the number of virtual platforms today. Few of them are subscription based, few of them are free as well. So one of them we are going to look into today. Immersive technologies in virtual labs. They have a great role that, in particular, that AR and VR are immersive technology that can enhance, the experience and the whole environment that it creates, and engagement with the students is revolutionizing the education sector for sure. And AR overlays the digital information on the physical environment. Also, virtual VR also created a completely, let's say, a simulated environment. I used to remember that I got a chance to use these VR tools while I was working in industry, and that has a very different experience of learning. And that also includes different design principles, let's say, aligning learning objectives, outcomes, and assessment with the affordance and limitation of the chosen technology, and also instructions, guidance, feedback to support learners, navigation, interaction, and comprehension in the virtual environment as well. So they have a massive role, and we are going to experience that, let's say, in our project as well, in the upcoming few years as well. And there are a number of, let's say, use cases for that. I'm not going into that, but immense number of, let's say, use cases exist for the, let's say, AR and VR both. So we are heading to, let's say, let's say, popular platform. Let's say Labster is the first one, is a subscription based. What it is about, it's offer wide range of engaging and gamifying simulation across different subjects that you see here, biology, chemistry, and environmental science, integrating well with the learning management system as well. So uh, the second one is PHET interactive simulation. Which one? This is let's say developed by University of Colorado, and it is free. And we are going to look into that. Let's say what it is about, and maybe some let's say interactive simulation, varying different parameters, how they react, and how we can let's say make our students understand that how actually it works, the whole concept. Semi-scale is again subscription based, not affordable, let's say, by everyone, as I mentioned, that under developing or developing countries. And even some of the, let's say, in developed countries, institution, let's say, resist to pay subscription fees. But it's all, again, whoever can afford, can go for that based on the requirements that, let's say, teaching has. Focuses on the simulations like CFT and heat transfer suitable for engineering discipline in particular. Exploring learning instruments, subscription based again, offers interactive science simulation with the focus of inquiry-based learning and STEAM education. One who is looking into, getting into the STEAM education and also, let's say, inquiry-based learning, should explore that particular platform. Is very interesting as well. The last one is Virtual Labs by National Taiwan University. Is again is a free virtual lab across various disciplines focusing on fundamental science experiments. So these are only five of them we have mentioned. There are number of other platforms. We are not saying that these are only the existing ones, but significantly popular among the other platforms as well. So how you can choose the right platforms? The first one is subject area and the target audience. You need to identify your subject area and also your targeted audience. Let's say what is age, skill level, these parameters that you need to, let's say, look into. And based on that, let's say you go on, let's say, for the particular platform. Functionality and features, what they are offering, let's say pre-lab activities, gamification, and that, let's say, has a match with your teaching approach, whatever you are teaching in particular to in the lab as well. Cost and accessibility, I think, is a one of the major factor that you need to look into. Let's say either to go for the free or subscription based. It's all, let's say, depends on the individual or the specific cases. Integration with the existing system, let's say, ensure compatibility with the existing learning management system used in your institution, is again very important. So these are some of the factors that you need to look into while choosing the right platform for your teaching or conducting the lab virtually. So platforms, we are going to look into, let's say, one of the platform, PHET interactive simulation, and what it is about. uh,
So FED is a collection of over 100 interactive simulations for teaching and learning science. They're all free on the web. You can run them online or you can download them to your computer. We have simulations in physics and chemistry and a growing number in earth science, biology, and math. One of the main goals of FET is to provide students with an open exploratory environment where they can really engage with the science content like a scientist.
The FET suite of simulations is one of the most carefully thought out simulations that we have employed in our instruction.
We conduct our own research so that we're constantly.
So these, I'm not, let's say, going to that. We'll look into that, let's say, uh, that platform. So this is, let's say, the homepage of that, and whatever the simulations they are offering, this in the physics, in the chemistry, in the maths, let's say in the earth science. There are number of let's say simulations that you will see that if you want your students to, let's say, transfer the concept, how does it work, this whole thing. These are very effective, and I have seen that myself. And let's say if you see that, the resistance in the wire, let's say any sort of the concept, you have that kind of formula for that particular concept, and you can see that, okay, varying different parameters, how do they change, the other parameters, how effectively, or let's say you can transfer, let's say the whole concept to your students. And in my opinion, it's a very effective tool. In particular, I have used this one, and also because it is a free and can be used by anyone. So please go ahead and, maybe you can utilize that, and maybe share some comments or thoughts on that, how, let's say, how you feel about that. So this is one of the, let's say, platforms I had to get a chance to look into. And just to, let's say, conclude the topic, the presentation today, by leveraging, these immersive technologies in the virtual lab, can effectively help educators creating a dynamic and engaging learning environment. For sure, it will, let's say using those, let's say AR and VR technologies into the learning environment, virtual learning environment, that will create an engaging and dynamic environment that complements the traditional lab experiences. Very different from the traditional lab experiences. We have seen the number of benefits and the functionalities it offers, and that will lead into, a deeper understanding of scientific concept for the students. You have seen that, okay, one of the platform that I've just shown, that how effective this is. You can see that by changing different parameters, let's say understanding the whole concept of that. So I would say that, okay, very effective these platforms are. Please go ahead with that and share your experience with us and as well. And with that, I conclude my presentation. And if anybody has any questions related to that, please do ask. And I thank you very much for listening to me. Thanks a lot.
Thank you very much, Kapil. Floor is open. If anybody has any questions, please feel free to ask. I and Kapil would like to respond if there are any.
Hi, Kapil. Hans here from MTU Ready program. You mentioned security could be an issue for you around this. Could you maybe just elaborate a little bit more on that, please?
About the virtual platforms.
Yes, correct. Yeah.
Yeah, well, this the technological, let's say whatever you build on based on the technology, some sort of, this external vulnerabilities or malfunctions, they always vulnerable, to, let's say, those kind of attacks, in particular. And I believe, this is one of the, let's say, major issue that will be, let's say, in the future you will be looking into, and one has to come up with, let's say, maybe existing solution, maybe, and also maybe a new model of, let's say, interacting with, or let's say, how we can defend those particular threats. We are all aware about, these cyber attacks, cyber threats, coming up with different, let's say, softwares, or let's say those who are open source, or let's say freely available to access. So they are more vulnerable, and one has to, let's say decide on the security feature as well, and also come up with a different defense mechanism for sure, I think.
Okay, great. Thank you.
Just to add on to that comment by Kapil, I just would like to say, like, the platforms are quite dependent on various number of software components, and those components, with the passage of time, if they're not, usually they are designed by, for example, DevOps or some automated platforms or stack, programming platforms, then the security is not usually catered by design. And there are a lot of issues when those components they're not patched up, they're not well maintained across the number of years. They get really vulnerable to many bigger threats and landscape of attack vectors.
Yeah, of course, of course. And can I just ask one more question, if that's okay, please?
Yeah, please go ahead.
Kapal or whoever. You mentioned the technical issues as well, so internet connectivity, and I assume we all know that Ireland, especially rural Ireland, where we are, I see it from going from one campus to the other here in Kerry. The one campus would have great Wi-Fi connectivity or network connectivity. The other campus would have really poor connectivity. Um, uh, Again, how are you guys addressing that? Are you considering offline versions of your software? Maybe that.
Yeah, of course, this internet connectivity, not but in particular to the Ireland, we are talking about, this around the globe,
Yes, of course.
And I also come from, this interior part of the Pakistan, and where I know that the internet connectivity is very poor. And
Yeah,
so how we can reach out to, that particular audience, and let's say the focus should be that one because they don't have the access to these sort of technologies or the platforms. And for sure, I think one way of to go, I think the best way is to go for, this offline virtual platforms, where they can, have this great experience. And I think that could be, great solution for sure. And I haven't, let's say, have gone, deep into the, let's say, more of literature that, okay, these offline platforms do exist, they don't require, this sort of connectivity. But if they do exist, I think that would be a game changer, and also will surely will put into, our let's say literature that we are doing, let's say deliverable and the stuff like that, we're going to put that for sure. And
that's
thanks
great.
for highlighting that, and if you know that, any sort of that platform, please do share, and we'll be happy to, let's say explore that and share around the globe,
That's
Just
great.
to
Thanks, Tony.
exemplify, just to exemplify and elaborate a little bit more onto that, like there is an example we have currently, we experienced over the number of years, we had some platform we used for cybersecurity testing and training purposes. And that was basically a platform which was acquired from a well-known company called Siren. Now, the problem, a lot of times, there was a big issue when students were trying to engage and interact with those from the campus because you need to have a very strong internet connectivity. And over the years, we observed like there was a lot of challenges and issues, and especially when there are a huge number of students trying to access the similar labs, we came across several challenges. Recently, we moved into more like an offline aspect of it. So we deployed recently a local Kubernetes cluster at the university. I know, I mean, this is a trade-off in building a new infrastructure for the university, and obviously there is a cost factor in there. But that came out a pretty good solution to the students on campus at least, as well as whoever has the VPN access to the network infrastructure to the university, they can still have access to the offline Kubernetes cluster, and they can basically, utilize the resources available locally.
Okay, that's great. Thanks, many guys. Thank you.
Thanks, Hans. Good to see you again.
Okay, so I just have anybody else has any questions, guys?
Hello, can you hear me?
Yes.
Yeah, thank you first of all for your good presentations. I also have one previous Erasmus project is about virtual learning, but it's focused on textile. So I want to ask you which test you will focus with this project. It's about engineering laboratory, but do you have a number, a specific number, or which tests will you create training materials with this project, with this Horizon project?
I'm not fully, let's say, sure that I understood the question. She's targeting that, okay, she's asking that which vertical area that application area will be targeting. And
Yes, with this project, yes.
and so we won't be, let's say, targeting any specific area. That will be generic, and that can be useful for any sort of vertical areas, And this is maybe engineering in particular, textile or whatever, this, let's say, the area is. So it will be generic, I believe. And I think, more of maybe Firat or somebody else want to, let's say, comment on that.
Sure, I can
Okay.
explain a little bit more. Especially this project is not about creating a material. We are going to create. We are going to find. We are going to choose a field to create. But the purpose of this project is to try to understand how to create virtual lab by using the effective learning methodologies and then learning instructional design models. So we are gonna make small example for that, which we are gonna try the model that we choose. That's why we're gonna try create a learning environment based on that model. So basically, as Kapal said, that is not specifically targeting any field of engineering. Is targeting the area of the engineering to show or to give a guide. This model and this model, you can do this kind of project actually. But as I said, we are going to create a learning environment to show and to see how this instructional design model that we chose or we created or developed work in this specific learning environment.
Okay, okay,
Clear enough?
understand. Okay, thank you.
Thank you.
Thank you, Firat. Thank you, Sabda, for the question. Anybody else has any particular questions in relation to whatever progress we have made so far into the project? Okay, next is Misa. So Misa, I've already made you co-host, so if you would like to share your
Sure.
thoughts.
Okay. Can you see it?
Yes, we can.
Okay. Can you hear me well?
Yes, you're loud and clear.
Okay. Okay. So as Firat already pointed out, the project is still early on. So we would want to present some good case studies on how to use the virtual reality in an engineering lab, but we don't yet have them. I hope we'll have them soon. So I'm going to present kind of what was the what we think or how we think virtual reality could benefit us as an engineering laboratory. So I come from National Institute of Chemistry, more specifically Department of Catalysis and Chemical Reaction Engineering. So we are a research institution. The profiles we have, it's mostly chemical engineering, but also chemistry, pharmacy, biotechnology, and some outliers like biochemistry and even a biologist, which is me. So there's a lot of people in our department. So this is not the whole institute, this is just us. So we have technical staff, researchers, PhD candidates, and we have actually a lot of students. However, the students here have a slightly different role than the students at the university, because at the university, the students are expected to learn and the instructors are expected to teach them as much as they can. Whereas the students, when they come to us, they are kind of expected to work and produce results. And the instructors just give them instructions with minimal effort because we don't have time. So these are some of the things that we are working with. So we have a lot of hazardous chemicals. We have machines that work at high temperatures, high pressures that can be very dangerous. And we also have very expensive machines, 100,000 euros and upwards. And you can be an expert in something and it can still go wrong, which is Exhibit A. Luckily, it wasn't too bad. So you can imagine how bad things can get in a laboratory like this if you're a student with no laboratory skills. So how do we instruct the students? Well, we first, of course, start with the theory. So shortly explain the background, the experiment, what it is about, why we're doing it, and how to do it, and then the analysis. Again, what will we do to analyze it? How will we analyze it, and so on. And then we go to a very, very important thing, which is laboratory safety rules. So protective gear, goggles, lab coat, gloves, no food or drink in the laboratory, no shorts or open shoes in the laboratory, cleaning after yourself, properly disposing of the waste, and so. Then we go to laboratory work, which is composed of the experimental part. So we show them experiment, how to prepare, how to do the experiment, how to prepare the samples for the analysis, and then show them the analysis. In this case, it's an HPLC. It's a pretty general thing for many laboratories, not just ours. So this is a high pressure liquid chromatography. So we show them this is the machine. This is where you put the mobile phases. This is where the samples are. This is where the column is that separates compounds, and this is where they are then analyzed. And then show them the software, how to prepare the machine, how to set up the method, how to measure. And then afterwards, the student does it by themselves under supervision, and then we kind of expect them to work independently. And if we stop at point 3 or maybe even 4 and ask ourselves, does the student now know how to work in a laboratory? Are they skilled enough to work safely for themselves and for the equipment? Or the answer is definitely not. We do get some students that are little geniuses, but that is maybe 1 or 2 in a few years. So how do we increase the understanding of the students, including the danger of damage and personal injury? Well, on one side, we have the theory. So a more in-depth explanation by the instructor. They can also read the manuals for the machines. They can also search the internet, maybe even look at some YouTube videos. But the main issues here is lack of time by the instructors. Like I said, the main goal is producing results. So we don't have enough time to teach them everything. And the other one is lack of motivation by the students, because no student is going to pick up a manual and read it. Not many students will go search the internet to kind of broaden their knowledge. And also listening to your instructor for a few hours just so they can explain all of the background, it's pretty boring. So we are visual creatures, so we need something else, you know? And then we come to the practice, which is on the other side of this bridge. And there it's repeating the experiment or the exercise and also experimenting with different settings to see the outcome. Well, here the main issues are a huge risk of damage or personal injury as a result of lack of understanding. To put it really simply, would you let a student experiment with a machine that costs 100,000 euros? Well, most likely not. So how could we bridge this gap? It's basically by a very good virtual laboratory. So where and how could we, as an engineering lab, incorporate this virtual laboratory? Well, first, in general work and safety in the laboratory, this includes just the general work in a lab and also safe work with a certain machine. We could go from the basics, putting on a protective gear, lab coat, gloves, glasses, check the chemicals that you will be working with. Do they require any additional protective gear like goggles, or do you need to use the fume hood? And then do a simple experiment. So prepare everything, prepare the working space, how you handle chemicals. Do you pour them into a beaker or do you pour them directly? Then pipetting, measuring, and at the end, very importantly, how to dispose of the waste properly and cleaning up after yourself. And here, what we think is also very important is show what happens if things go wrong. So if you're not wearing gloves, you see your hand gets burned. If you're not wearing a lab coat when handling chemicals, well, you get burns all over your body. Or if you're wearing shorts or open shoes, or if you're not using the fume hood, well, you fumigate the whole hallway and someone might pass out or at least get a very nasty headache. And then if you put the wrong settings on a machine, you get a very high temperature or pressure, there can be an explosion or a fire. You're not paying attention to what you're doing in general, well, many things can happen. You can trip or something, you know, and you can cut yourself on broken glassware, stuff like that. And also not cleaning after yourself should get you kicked out of the lab, you know. So this could also be used as an entrance test for laboratory work. So you first kind of do the introduction with the theory, then you put the student into the virtual lab, they perform the test. If they pass, they may enter the laboratory. If they don't, I'm sorry, but you have to redo the test. Why is this important? Is because a lot of these things that I just listed happened already. We had chemical burns on the face because someone was touching their face with dirty gloves. We had chemical burns on the face as well because someone touched the doorknob with a dirty glove and someone else touched it and touched their face. We had, fumes in the hallway. It was really bad. We also had smaller explosions. We also had a fire at another department. A lot of cuts and things like that, but also a lot of damage to equipment. So this is very, very important. It seems simple, but people need to see it. People need to see what can happen to you. So it's the visual material that gets them engaged. So another part where you can use it's work with a specific machine. It's something that Kapalo already mentioned before. So in this case, the HPLC. And let's say you can start from the beginning. You can actually select an analyte. You say with large molecule, polar charge, and based on that, you select the correct column and then the correct mobile phase. And then you can prepare the samples. So the volume of the sample, the correct filter for filtering the samples, then prepare the machine with all the purging of the system, washing of the system with the appropriate solvent, setting up the temperature, putting the column on and so on, and doing the measurement. And then experimenting with different settings. For example, different ratios of the mobile phases or different injection volumes. This is good as well because a student could see the inside of the machine, so understand the working of the machine, which tube goes where, how does the sample travel through the machine without actually opening the machine every time you get a new student, you know. And here as well, the what ifs. So if you select the wrong column for the analyte, or the system isn't purged properly, wrong mobile phase, samples not filtered, and on, you get high pressure, air in the system, particles in the system, you get a clogged column or a broken column, and at the end, you get a machine that is out of order. You need to call the repairman and can't work for a while. And this is very good as well because a student could practice without actually taking up space or time on actual machine, which is used for, well, obtaining results, which is our major goal. So kind of in short, the advantages we see of incorporating VR would be to gain better understanding of a specific process or a machine operation. The students can experiment without the risk of damage or injury or taking up time on a machine. Students can repeat the experiment in their own time as many times as needed and also at their own pace. And it could be used as a test of skills before starting actual work in the laboratory. And the last one, a more relaxed environment, is something that actually a colleague of mine who used to be a teacher pointed out. And she said, I told her what we were doing, and she said, you know what? I would be so much more relaxed working in a virtual lab than in an actual lab when someone was standing behind me, you know, looking over my shoulder and seeing what I'm doing. She said, I would be so much more inclined to try different things, to actually experiment, if I was kind of in my own little bubble, you know, and I didn't have to think, you know, I'm going to be embarrassed if I try this or that. So this is really important. It's also offering a kind of safe environment where students feel confident enough to actually experiment with the task. So this is kind of how we envisioned a virtual laboratory would really come in handy in our lab. But I hope we one day get there, because this is a very, very hard task to do. So thank you very much. Any questions?
Thank you, Misa. Thank you very much. That was very informative, and it's a kind of a very interesting case study, especially when we are dealing with the hazardous and dangerous chemicals on a daily basis. So I think it's a very interesting case study. Floor is open. Anybody has any particular question? Maybe any person who is more into the same domain as Misa is and would like to share their experience or any particular case study they have. Okay, it seems like we are well into time, and last but not least, we have a very interesting another case study at MTU Curie campus, and we have a representative from MTU Curie campus. This is an ongoing project from more than 20 global world leaders working on education engineering, and this is a very successful case study deployed for manufacturing and mechanical engineering, which is basically a program, a full-time program running in MTU Curie campus. So we have Hans from MTU Curie and will be presenting and sharing his thoughts. Hans?
Hi guys, thank you. Thank you. Just give me 1 second till I just figure out how to share my screen here.
I'll just try and make you. Yeah, I'll just make you a co-host.
Let me just make sure I'm sharing the correct one. Yeah. So hopefully you can all see my screen there.
Yes, and you're loud and clear.
Okay. Hello all, and thank you for allowing me the opportunity to present on behalf of the RAID program here today. My own name is Hans Moomen. My background is software development. I specialize in immersive technologies, and I'm part of work package 3 on the RAID program, which basically covers the integration of immersive technologies into the mechanical and manufacturing engineering degree course within MTU in the RAID program. Just a kind of a brief background on the RAID project as well, how it was created and how it's delivered. It's based on a model roughly based on a model developed by Professor Ewan Lindsay at Charles Sturt University in New South Wales, Australia. But it's based on world-class engineering education. It was co-created with Enterprise, so that basically means that before the project started, the team went out to industry and through workshops, questionnaires, feedback loops, so on and so forth. The RAID program was developed, so it's heavily integrated and created with Enterprise as well. So emerging technologies, like I said, we are integrating immersive technologies where we can in the course. Obviously not, it doesn't fit everywhere, but where we can, we do integrate it within the course as well. It's project-centric learning, so the students learn just in time, not just in case. And it is based on continuous assessment as well. So there's very little end-of-year exams. It's continuous assessment based on written tests or not feedback, but assignments and so on and so forth as well, practical assignments. Student-led activities is co-curricular and extracurricular as well. So I'll touch on that a little bit more just in a couple of slides. All our lecturers are engineers and residents, so that means basically that they have a wealth of industry experience. They're not purely academic. So all our lecturers are from industry, basically. And then we also have a number of mentorship and support frameworks works in place for the students as well. So just quickly going through our partners here. We have a number of academic partners as well as research center partners. So obviously we're part of MTU, but we've also partnered with Harper Adams University in the UK, University of Limerick, Charles Sturt University in New South Wales, and Aalborg University in Denmark. Our research center partners are IMO Research Center, Lero, Confirm Smart Manufacturing in Limerick, and the ACE Agritech Centre of Excellence here in County Kerry as well. So just in terms of our partnership and what that allows us to do and what that gives us access to is, for instance, through our partner ACE Agritech Centre of Excellence, they've installed a virtual reality suite within the MTU campus as well. So what you're looking at, that image there is a 5-meter curved screen, interactive, immersive space for the students to do various labs in as well. So it's got a floor projection. It has equipment up on the walls where the students can basically monitor or mirror the content that they're seeing in their headsets up onto various monitors, and the lecturers can guide them through sessions as well without taking them out of an immersive experience, if you like. Our enterprise partners, we have a number of enterprise partners, mostly in this southwest region of Ireland. We have one up in Mayo, and we are looking to expand this throughout Ireland nationally as well. So the partners range from medical, say for instance, Stellis and Killorglin here locally, or Stryker Medical. We have Ag Engineering, Dairy Master here locally as well, McHale up in Mayo, and Abbey Machinery, and also heavy engineering, for instance, Lieber Cranes, based here in County Kerry and Killarney as well. So a number of those partners as well. And like I said previously, these partners were on board when the program was created for the MTU. Just a quick snapshot there of some of the students. They're given a unique opportunity to explore and grow. So with our close collaboration with our industry partners, basically, our students are able to go and visit these enterprise partners to get a feel for what it's like for an everyday engineering. So, you know, they get a feel for, is heavy engineering for me, is ag engineering for me, is medical engineering for me. So they get exposed to a wide breadth of experience as well. So bottom right there, you see Minister Simon Harris basically launching the program back in 2023. And the student-led activities, the co-curricular and extracurricular activities, the bottom left image there is that our students are encouraged to participate in extracurricular activities. For instance, our science festivals, open days, career days, where they promote STEM to the younger generation as well, and try and get them excited about a future in engineering in particular. Just going on to the next one here again. A number of design and engineering workshops that's been done. We had our engineering symposium where our industry partners were brought and our students were brought together in a big space. The students could present to the industry partners, and then we flipped it and the industry partners could present to the students. And it gave the students an opportunity to, again, you know, get that dialogue going with the industry partners about where they will be going for work placement, because one of the key elements for this project is 2 years work placement rather than just 6 months. So at the end of this September, the second year students will go out on 2-year work placement with their chosen industry partner. They have to go through a formal interview process and everything, but the benefits of that is students will get that 2 years experience. It'll be a paid placement as well. And the immersive technology will come into that then at that stage. So I'll just play a short video here. I hopefully it should be. Sorry. So just a quick overview of the program and what it's all about. Okay. So where we've implemented immersive technologies within the course is we don't force it into the course. Basically, if it does fit, we will integrate it. But sometimes, you know, a PowerPoint slide is sometimes just the quickest and easiest. So as you can see from the graph there, years 1 to 4, about 55% of the whole course is covered through some form of immersive technology, of this VR, AR, MR, XR. We've incorporated it. So I'll briefly talk through a couple of examples, and I'll show you some videos as well. I'll probably explain a lot more, being visual creatures and all. But for instance, Engineering Challenge 1 and 2 heavily incorporated there. Professional development and production engineering and materials engineering as well is where we have mainly focused it on at the moment. So just going through the next slide here, my colleague, Michael Noctor, he's a learning technology specialist. He couldn't join us today, unfortunately, but he's given me a couple of notes to read through here, and I'm literally going to read them. I'm sorry, I'm not a learning technology specialist, but we are integrating immersive technologies for various reasons. So literature has shown kind of over and over again that people learn a lot better, retain information longer, recall it better if they use immersive technologies in education. So our pedagogical approach integrates elements of various learning theories, but is heavily weighted towards the theory of constructivist learning, with active participation of the students during lectures, tutorials, and practical work central to the approach. The key to enabling active participation during the face-to-face time is the upfront and asynchronous delivery of course content online. This will develop students' foundational knowledge of a topic before they take part in face-to-face learning activities. This is essentially a flipped classroom approach whereby teaching and learning is shifted away from a more traditional form of teaching, led and teacher-centric delivery, to one where the lecturer's facilitator of learning and face-to-face time is focused on applied learning activities. You can also see the indication here that continuous formative assessment is fundamental to supporting our approach to teaching and learning. So next, I will just go on to show you a couple of examples of where we have integrated immersive technologies in various forms. And as the video plays, I'll just talk through them as well. So the first one here that you will see, turn the volume down there. So this is what was taken from Charles Sturt University. Is it's called the Rube Goldberg machine. If anybody's familiar with the concept or the term, it's achieving is a very simple outcome through an overly complex process. So what the students are given, they're given a start location in a room, in a virtual room, and an end location, and they have to get from the start to the end any which way that they can, using a number of principles as well. So they can use dominoes, they can use balls, they can use catapults, they could use whatever is available to them using virtual reality headset dock, the Quest 2 that we use. The benefit of this is that the students are introduced to immersive technologies. So each student gets their own VR headset day one, and they keep that for the 4 years. So every year, every student gets their own VR headset that they get to take away with them as well. So they can work away with these projects in their own time and at their own pace as well. It also introduces them to engineering principles. So you'll see there's catapults, there's bowling balls, there's push mechanisms, there's pull mechanisms, there's a hammer, a pendulum type thing. So they learn engineering principles as well. The good thing about this is we don't have to go out and buy these resources for students. So we don't have to go buy a whole set of dominoes. We don't have to find a room. There's no health and safety issues involved. So like these are things that's been covered in all the slides previously as well. There's just huge advantages to this. The other main advantages to this, as doing it in a physical space, is if you get to the end and you figure out that that you don't reach the end, basically, you flick a switch and the whole thing resets instantly. You don't spend hours having to reset all the dominoes manually and so on and so forth. So that's it's an off-the-shelf application that we got. So basically, we get a whole bunch of licenses. We install it on the headsets for the students. They're given a bit of guidance, but they're free to explore then. The next one that you will see here is this is based on the let me just see the production engineering module. So in this example here, we've used the Microsoft HoloLens. If anybody's familiar with it, it's an AR technology where students are required to build a Lego motorcycle, like you see up on the screen there, a simple Lego motorcycle. One half of the student group were given the manual instructions, so the little booklet that comes with Lego instructions. The other half got given the HoloLens with the digitized instructions as well. Excuse me, I have a bit of a cough, excuse me. So you can see here, the students can build along with it, but there's also supplementary information about it. There's a tutorial video that shows you how the parts go together. So basically, we timed the students using the HoloLens versus the students using the manual, and we also compared the results at the end. You know, the kind of success rate. You know, it was the front wheel at the back, say for instance, or you know, did they swap the handlebars over by accident? And we found that the students with the HoloLens did build it faster and much more accurately as well. So in the interest of ethics, we obviously switched the groups there as well. So one group wasn't at a disadvantage to another group having access to the technologies, basically. Moving on to the next one. So what you're looking at here is, this is part of Engineering Challenge 2. So what the students were required to do is build a pipe crawler device. So pipe crawler device is literally what it says. It's a little device that can traverse up and down a pipe. So the lecturer presented the challenge to them in virtual reality. So they were all joined together in this room. That's the lecturer's notes up on the wall that you see on the left-hand side. The pipe was going to set to an initial incline there. I think it was something like 15 degrees, but the challenge was to get the pipe all the way up to 90 degrees then as well. So that was lecturer's example that he built himself. So you can see that the little pipe crawler goes straight up and 90 degrees and straight down again, very controlled. And the students were asked to replicate that. So it wasn't introduced in virtual reality to them, and then they presented after they completed the module. The student actually presented in this space as well, so they were allowed to bring in their own documentation, as you see there. They did a little recording of the test that they'd done as well, and some of the students also brought in their CAD models. As you can see, that there's a CAD model up on the table that they had designed, and that's the actual machine that they have as well. And from this, we found that some students that were maybe shy or reserved presenting in real life, they could really shine in this environment, because even though you had your peers around you virtually as avatars, they were much more relaxed. You know, some people just kind of really clam up when they come to that public speaking. So we found that the students really kind of some students really came out in virtual reality, which was very interesting to us, and it's just a nice experience for them to have as well. So the next one I'll go on to is soft and transversal skills. And again, this is something that came out from that initial design with industry piece, is that student engineers might come out and they're brilliant engineers, but they don't have the soft skills or the transversal skills, say, for instance. So it might have been the first time ever in their life they're doing an interview or having to talk to or do a presentation to the crowd, say, for instance. So we've introduced a model called body swaps to them, and in body swaps, they can do a number of tasks, basically. So for instance, navigating angry conversations, negotiation and conflict management, gain influence and value, public speaking. So there's a whole bunch of content there available to them again, and fully virtual reality. So they put on their headsets and they're talking with the avatars on the screen as well. So the image at the bottom left there, you see they get digital badges. So that's a form of gamification for them. On the top right-hand side there, they were required to complete these modules based on interview skills and communication skills, and they were required to do that before the engineering symposium when the industry partners were on board, to improve their communication skills. And the vast majority of students did report that body swaps did help them improve their communication skills when it came to the industry day. And the bottom right-hand side there, again, we get a vast number of analytics and activity feedback from these resources as well. So for instance, we can see when they're online, what they create, how long they spent online, basically what they've done, not spying on them, but it's valuable metrics for us as well to validate the program. Moving on then, the next one is again, we try and get off-the-shelf content as much as we can because, as everybody here probably knows, creating a virtual lab from scratch takes a long time, costs a lot of money, and it just requires a lot of resources. So what we do is we try and get content where we can off the shelf. This is a tensile strength testing lab. It's very short. That we the base of it was created, but we customized it then for ourselves as well. So for a particular machine that we have within MTU, we based it on that. And as you can see here, it's all very interactive. So the first part is you put the little clamps on the machine, then you go and pick your material. So there's different materials, different diameters, different lengths, different shapes, different sizes. There you see you actually physically switch the machine on. Then you tighten the clamps down onto the piece of material there. So you'll see it'll clamp it down. Then you go over to the control unit, and basically you start the whole process. So you can set the speed and the force of which these metals are stretched or compressed, and you'll get a reading then from the end as well that the students would then give back to the lecturers, and that would be graded then based on what they were doing. So just a very informal kind of feedback questionnaire we did after our first cohort. The strengths, they reported it was engaging and motivating as well. So so it helps with problem solving, training, practical ways of learning, more enjoyable than sitting in a classroom. So huge strength for us as well. The only challenges that we are experiencing at the moment is virtual VR sickness, basically, so motion sickness. Some students that complain of motion sickness as well as eye strain as well. But again, we have rules, regulations, and procedures in place to mitigate that. So say, for instance, if the students are using this in a classroom environment, that you'll use it for 10 minutes, then have a 5-minute break, then maybe a 15 minutes, then another 10-minute break. So we're kind of strict on that as well. Unfortunately, when the students have the headsets at home, we don't have control over that. And I think that's where the kind of issues arise for us as well, is that it's not kind of regulated there, but it's all good. So just the program in general, our education and public engagement. So we've probably visited every school in Kerry at this stage, and what we have is we are calling our River Kit. There's 20 headsets in this kit that we roll out to schools, and the students get up to put on a headset, and they get to do virtual reality experience as well, and it just gets them a little bit excited about STEM education as well, and now at the Ready program as well. So we have Striker Wise, we have iWish collaborations, we have outreach activities. So we're heavily involved with the community and getting the younger generation, especially involved in STEM education. Just getting to the end here now, is our impact, the impact that the project has. So we've published a number of book chapters there. So the one I was involved is Learning with Technology and Technologies and Learning, again, using AR and VR in education, and specifically engineering education. We've had a number of journal publications as well as conference publications as well. Most recently, I presented at CEFI around revolutionizing engineering education through photorealistic virtual human lectures using AI and computer-generated images, that I was quite passionate about. Lastly, similar to that, we are launching our Virtue Network as well, which stands for Virtual Immersive Reality for Transformative University Education. And the goals are to develop a national framework to enhance and standardize the use of immersive reality in education and ensuring consistent quality across institutions. So through our journey and through our other HCI partners, we've discovered that everybody's doing the same thing, but kind of siloed. Everybody figures out that the Quest 2 headset is the best. On their own, that might take them 6 months. Then they figure out PNX Labs. They have a whole wealth of information and labs that you can just buy off the shelf and use them straight away. And again, that might take another 9 months worth of research to get to that point. So there's no real standardized format out there as well. So we're very excited about this at the moment. The first meeting will take place on the 12th. It's only open to HCI partners at the moment, unfortunately, but we're hoping to kind of roll this out nationally as well in the very near future. So yeah, that I hope I wasn't over time. I hope not, but that's it for me. Thank you for your time. Thank you for your consideration. And if there's any questions, I'm happy to answer them.
Thank you very much, Hans. That was very informative and a very interesting case study. I don't know if anybody else has any questions, but I may just take priority. And I wish to ask one question, Hans, is that, so you have these virtual lab environments and you have like kind of a continuous assessment. How do you map those together? So what is the role of virtual lab learning and how it impacts the continuous assessments? Like, is it made part of their continuous assessment?
Yes, yeah. So in for especially Engineering Challenge 1, it is part of the continuous assessment. So they actually get graded on that piece as well. So the Rube Goldberg machine, they have a start and an end point. And then when it comes to the assessment day, the lecturer will run that Rube Goldberg machine of each student. He'll run it 3 times, and they'll have to get a certain percentage of pass marks over those number of times as well. They're also building in, say for instance, emergency stop procedures where it's the same as a production line. You know, if there's a conveyor belt and an accident happens, that you can hit stop button, the whole thing stops immediately. So they're implementing that into the thing as well. So that the lecturer will call out stop. The student will have to have built-in mechanisms to basically cut off the dominoes path, say for instance. So it does become part of the continuous assessment in that case. The PNX labs as well, the tensile strength, that's again, it's part of the continuous assessment piece where they're given a task to do a tensile strength on a certain type of metal, certain diameter, certain width, certain length, certain pull speed, force, all that kind of stuff. And they have to generate basically an Excel sheet out of that as well. The Synergy XR piece, it's not part of the module per se. They don't get graded on it. But it's integrated into the module as a deliverable, same as the body swap. Body swaps is part of the module or the CA, where they do get graded on. Did you do your communication labs, and what was your score at the end? Because it does actually score you based on on how you interact with the virtual avatars and what. So if it's an active listening piece, so an avatar might say, my boss was shouting at me for X, Y, and Z, and then they'll give you a couple of answers to give back to the person. And based on that, you could either end up talking about yourself, which is wrong, or you can, encourage the person to talk more about it, which is the right kind of approach. So they do get graded on that, yeah.
Perfect. That's a very nice and interesting case study. The floor is open. If anybody has any other questions, please feel free to overwhelm Hans with his knowledge and experience. Okay. Right. I don't hear anybody. So I think everybody enjoyed the number of presentations and the case studies presented here in this workshop. I would just like to request everybody that if you can, I'll be sharing a questionnaire based on the evaluation matrix. So it's a very quick, it may take not more than 1 to 2 minutes for you to basically submit your response. This is kind of an evaluation questionnaire related to this particular activity, and it will be appreciated. Thank you very much, guys. Thanks a lot. And in the end, I would like to take one group photo. Firat, will you be able to take it on behalf of us?
Sure, I can. And also, is it possible to put the link to the chat, by the way?
Yeah, I'm just gonna do that. Yeah. Mehmet, okay. Thank you, Mehmet. Mehmet already shared the link to the chat, so please kindly spare a couple of minutes to fill in the questionnaire. That would be a good feedback and evaluation for ourselves as well.
Okay. If everybody smiles, I'm gonna take it. Just 1, 2, 3. I took it just in case. Let me check if I did correctly. Oops. Nope, I need to check it again. Sorry. Okay. 3, 2, 1, and did it. I think I am all
Thank you.
set now.
Thank you very much, Bharat.
Yes.
I would like to thank you, everybody who has participated and contributed. It is greatly appreciated, and I look forward to working with you all. And please don't hesitate to send any response or any queries in relation to this activity, as well as if you get any interest. Please subscribe, as Farhat already mentioned about the various social networking handles. So please approach us. Share your case studies, your thoughts, your experiences over there. It would be a delight to get engaged with academic as well as industrial partners or SMEs. And we're happy to, collaborate and look for further networking. Thank you, guys. Have a good day. Take care.
Thank you.
Bye.
Bye-bye.
Thanks.
Thanks. Bye.
Have a nice day.